Okay, this is a video showing the prototype renderer for the game. Excuse the horrible lighting and texturing. I'm a programmer, so that pretty much guarantees I have horrible taste, and that's the excuse I'm using for the catastrophe that you're seeing in this video. It'll be interesting to see the changes as the game is developed, and this scene will pretty much serve as a baseline so that later you can refer to it and see how many changes I've made to the render as the game is developed. Again, this is just a test level, and this is in no way indicative of the game I'm working on. To be perfectly honest, the game I'm going to make is completely different, and it's in no way related to the level or scene that you're seeing now. This level is one that I used in the first game I developed, and I was pretty much able to develop the entire game using this one level. And again, I'm just using it for test purposes. The way I exported the level was to use Maya. I had a custom plugin that I wrote, and then that was used to export this scene into the renderer. For this next game, I will be using the custom level editor that I've been showcasing in prior videos. I think that's a much better technique, as it allows the artist to have much more control over the scene and the parameters of the game, and it also decreases iteration time so that the artist can see his changes much more quickly than, for example, doing things in Maya. And that's not to say that Maya is a bad tool. It's an excellent tool. It's just that for creating levels, it's much better to have a custom editor. And so that's the plan that I'm going with for this game. Now I'll talk about the lighting. Let's see, I'll go over here. What you're seeing here are box lights like the ones I described in the prior videos of the level editor, and as you can see, the fall off, there's a really sharp fall off. It's practically an edge. The reason for that is you can tweak the fall off in the level editor with the properties, and if you wanted a smoother fall off, for example, what you'll see in the spotlight, yeah, right here. As you can see, the spotlight has a really smooth fallout. You can barely see the outline. And again, that's something that you can tweak in the editor. So if you wanted a similar effect for your box lights, you would just change that parameter, and then you'd get the same smooth fall off that's more gradual, as opposed to having this really sharp edge. One good thing is that if you're an obsessive compulsive, you'll feel right at home in the editor, because everything is tweakable, every single parameter, so you can change things to your heart's content. The next thing I'll talk about is the shadows, so I'll head on over here. Yeah. The technique I'm using for the shadows is something called cascaded shadow mapping, and you can Google the term to find out about the technique. I pretty much wrote this in 2 days just to make sure that the theory was sound and that it could be implemented in the engine. This is one part of the engine that's going to go through dramatic changes as the game is developed. Eventually, when I release the game, you'll be able to change all the parameters for the shadows, so you can have no shadows, really poor quality shadows, right on up to the best of the best that you could have. One thing I'll say about the lighting is I'm using a technique called deferred shading or deferred lighting, whichever term you prefer. And again, you can Google the term. And the reason I've used this technique is it scales better when you have hundreds of lights in the scene. And that's one thing I want to have, a lot of lights in the scene. And it also is capable of running on low-end cards if you do some heavy optimizations, of course. And that's one thing that I'm targeting. I'm targeting the lower end cards so that a larger number of people can play the game. Now, that being said, I'm not going to use World of Warcraft technology. So I will use techniques that are more advanced in that type of game. But again, I'm also not going to go full Crytek and require a really powerful card. To give some stats, you'll be able to run at 720p at 60 frames a second on a really low-end card. And if you want 1080p at 60 frames a second, mid-range card will be more than enough. So it'll be fairly inexpensive hardware-wise to run this game. Another thing I want to show is the post-processing effects. Post-processing effect is sort of like a little special effect you can do once your scene has been rendered, but before you present it to the user. For example, here's an example of a post-processing effect in which I've turned the scene black and white. If I wanted to use another post-processing effect, here's another example. This is sort of like a night vision effect. Again, these effects are something I just cooked up. They're not going to be used in the game, and I just use them for testing purposes to make sure that the system is running the post-processing effects correctly. Now, one of the things that you can do is you can chain effects serially. So you can have a series of effects running, and the output from one effect will feed into the input of the next effect like a chain. And that's really a flexible system because you can have any number of effects running. You can disable effects in the middle of the chain, add to them. Another feature is that the effects are tied to a viewport. So if you have different viewports, you can have different post-processing effects running. So the system is built with maximum flexibility in mind. For example, if I disable the night vision effect, the black and white effect is still running because they're chained together. The other thing is I use data-driven design principles for writing this engine. So you don't need any C++ coding to enable these effects. Essentially, all you need to do is write the shaders for the post-processing effects, tell the engine where they're located, and the engine will automatically load them up into the renderer, and then you'll be able to see your changes. This is a great boon for artists, particularly technical artists, because all they need to do is write their shaders, change their parameters, and the engine will automatically load them, and they'll be able to see the results of what they're working on without needing a programmer or having to write any C++ code. So like I said, it's very flexible, and the artist can see his changes really quickly. And so that's pretty much all I have to say about the render. Again, this is something that'll serve as a benchmark or sort of a test bed, and it'll be interesting to see how radically the game changes as I work on this render. Now, one thing I'll leave with is if I leave the outside of the world, you can see there's a sort of psychedelic effect going on, and the reason for that is I don't clear the frame buffer since you're always rendering the entire scene. It's a small optimization, and since you'll never actually be able to leave the world in game, there's no need to clear the frame buffer. But it's an interesting thing to see. And as you can see now that we're out of world, everything's pretty much like a movie set, so it's just a facade, nothing's really real. It's just triangles, and that's what just gives you the illusion of that there's some depth to the scene. So now I'll just come back inside, do another final flyby. And that's pretty much what I'll leave you with. I'll start doing more uploads when I make changes or when I update the level editor, and if I make changes to the renderer, I'll also upload videos. Thanks!